Hello, in this video we're going to push this drive to the limits. We're going to start this flywheel up, then we're going to bump the speed up to 90 hertz, and then we're going to try to decelerate it really fast. Now with these drives, a very common problem is having over voltage on the DC bus during deceleration. On this drive, once the DC bus hits about 185, 190 volts, or sorry, 385 to 390 volts, it will trip on over voltage on deceleration. Now it's using, this does have a built-in resistor, but it is a very small resistor, and the drive does monitor the temperature of that resistor. So once we trip it out, we're going to connect up some cone heaters. The manufacturer specs says to use a 40 ohm brake resistor, external brake resistor, that you can buy from Mitsubishi. We've got these cone heaters. They're about 20 ohms each, so we've got two in, we're going to connect two in series. Okay, so I'm going to start it to 60 hertz right now. We are pushing this drive to the limit, so I have to monitor the thermal capacity, and you can see that's this bar graph at the top. Once it gets all the way to the right, it will trip on overload. You want to make sure that doesn't happen. So I'm only bringing it up to 60 hertz. I'm going to let it run at 60 hertz. The thermal capacity will drop. You can see that thermal capacity. Remember, during the acceleration, it draws a lot of current and it heats all the components up. So that's the beauty of these drives, is they have a lot of diagnostics built into them, and they basically protect themselves. Okay, so I'm gonna run it up to 90 hertz. Give it a second to get up to speed. That's up to 90 hertz now. Now I'm gonna change the display so we can see a little bit more information. And what I'm interested in is the third line down. It's at 289 volts. That is the DC bus voltage, 289 volts. And 90 hertz, 2.78 amps. So I'm gonna stop it and watch the DC bus voltage. That should go up to about over 380 volts. So 385, 387, 88, and they're over voltage during deceleration. And that happened when it was decelerating down to about 42 hertz. And if I shift out of this, you can see that RB, that means the braking resistor is overheated as well. So I'm going to reset it. That smells like it's burning a bit. Okay, so I'm going to power it down now, and I'm going to connect these two leads to the brake resistor terminals in the drive. Okay, I've hooked up the cone heaters. I take a jumper out to bypass the internal resistor. And you would, all drives are different. This particular Mitsubishi drive, I'm going to put the manual on learning hub so that you can see it. Okay, so I'm going to start it to 60 hertz. Yeah, it's around about 10 amps. We'll start. It's at about 45% thermal capacity. I'll let it drop down a bit before I bring it up to 90 hertz. just so it doesn't trip on overload. Okay, so we'll get up to 90 hertz. So the motor is going to be turning around 2,700 RPM, just below that. Okay, it's at 90 hertz. I'll shift so we can see the DC bus voltage. Again, that's the third line. It's at about 288 volts right now. It's going to trip at about 385 volts. It'll trip at. Hopefully, it doesn't get that high. Okay. I'll check that thermal capacity. Well, let it drop a little bit. Still a little bit high. So as it runs, it's only drawing about 4 amps right now. So as it cools off, that thermal capacity will drop down. The cone heaters are going to get red hot. No. 42 hertz. Yeah, so it tripped out. On over voltage during the acceleration at about 42 hertz. So at that speed, it's just a little bit too high. I'm going to try it. I'm going to restart it and try it at 80 hertz and see if we can decelerate from 80 hertz. Okay, I got it going 75 hertz. We'll see if we can stop it from 75 hertz without tripping. Okay, it's at about 290 volts on the bus. It's up to about, staying at about 380. That's good. These are getting red hot. Decelerating. It is stopped. So it kept it below 380 volts and did manage to stop it this time without tripping. So essentially what we have to do is we have to put these external brake resistors in order to dissipate that energy. One thing about the brake resistors, you can buy purpose-made brake resistors, but they do have a duty cycle factor, so you can't constantly start and stop it. And the drive, you can't really constantly start and stop it either. Remember the thermal capacity, we're at 0% right now, so we're okay. But it does heat the drive up when we start the motor and when we stop the motor. And we only really have to worry about this for higher inertia drives or drives that might have another load pushing on them. For a pump or something like that, you don't really have to worry about it. But my experience in working on sawmill equipment, this was the VFD problem we were constantly fighting and constantly trying to get the right amount of resistance and with the right deceleration time so the drive does not trip with the machine. Okay, good.